Right. So I'm going to be giving a talk a little bit about how to think functionally. That is, how to adjust your thinking when you are programming to make use of the functional paradigm. Hopefully nothing too complicated or awful. I'll refund all the money you paid at that door there if you don't like it. So I have been messing around with computers since this was the sort of thing that was the main computer I used to play back in my day. This is a ZX Spectrum. It had a grand total of 15 colors. 15, and one of them was black, and 48K of memory, and games took an average of about 5 minutes to load. It was brilliant. I absolutely adored it. But what I'm kind of saying is that I really am that old. I've been doing this for something like 20 years now, kind of still enjoying it. I'll carry on doing it until everyone tells me to stop doing it. I am from a small town that I almost guarantee that no one has heard of, called Telford. It's in the middle of the UK. If you kind of draw a big X through the UK, the bit where the middle of the X is roughly where I live. It's okay. Everyone's going to live somewhere. We do have a bridge. It's quite a nice bridge. This is the first iron bridge ever made in the world, ever. Hey. Which means that we have a UNESCO World Heritage Site, which means I have one thing at least in common with my wife, who's from Mumbai. They have the Elephanta Caves. We have this bridge. That seems completely proportional to me. I am also the author of this book. If anyone cares to scan this barcode, apparently O'Reilly will give you a month or so free on their platform. Joni, you might not need it. But I'll bring this back at the end. I have also done a couple of courses for them and things like that. Be warned, this is a very silly book because I wrote it and that's the way I write. So, moving on to the functional programming paradigm. Let's have a discussion about what exactly we mean by that. So, this is Kurt Cobain playing an acoustic guitar. This is Taylor Swift playing an acoustic guitar. This is Shania Twain playing an acoustic guitar, and this is Jimmy Page playing an acoustic guitar. The point is that these are four very different musicians, all of whom are playing the exact same instrument, but incredibly different styles of music come out. And that's what paradigms are. They are a style of programming. They are characterized by what you can and cannot do. Object-oriented is one paradigm, functional is another. C# is deliberately designed to support both. So, there are two rough families of paradigm. There are imperative paradigms. These are procedural OOP are examples, and these are very concerned with order of operations. So go here, go here, go here, loop around here, like you've got a little robot dashing around a course doing this, and very, very concerned with the minutiae of how exactly we construct everything and how everything works at a low level. Whereas functional belongs to another family of paradigms called declarative. Declarative is less concerned with the order of operations and more concerned with what you want at the end. We're more concerned with describing what we want and then leaving the details of the precise how and where and so on to the executing environment. So the basic tenets of OOP are abstraction, encapsulation, inheritance, and polymorphism. If you understand all those, well done you, because it takes a bit. Whereas FP, immutability, predictable side effects, free functions, predictable side effect free functions, functions over statement and stateless. Now, there is a commonly held myth that functional programming is hard to understand. I would argue that this is not the case at all. There are fewer things to learn. Plus, try explaining those things in the left-hand column to a member of your family who is not a developer. Just you try it, see what happens. It'll take a bit. Whereas the stuff on the right-hand side, I'm going to go through in a bit, isn't really all that hard to grasp, even if there are occasionally some bits of funky wording. And functional programs are constructed out of functions used like Lego bricks. What we've got is functions built on functions, using functions to glue them together, like each function is a brick, and we're building a building. And then you get larger, more complex behavior emerging from these clusters of functions. And there is a rule of thumb in functional programming. If the question is anything whatsoever, the answer is functions. And that roughly holds true. Advantages of functional programming. It is easier to maintain. It enforces good code structure. It tends to fail an awful lot less. Once a functional program is up, generally speaking, it tends to stay up and not fail again. It is more robust. There you go. The what's it called? The so-called $1 million mistake, the unhandled null exception, doesn't occur in functional programming. It's not a functional concept. That would be a side effect. We don't do side effects. And it is more testable. You can get a functional program close to 100% testability. Disadvantages, it is a new thing to learn. It's not more complicated than what you may have been used to if you do OOP, but it is different, and it does mean learning some new concepts, though I would again argue that the slope is a lot less harsh. And it can be suboptimal performance. Now, I should caveat this. That's in the C# world. C# not optimized for it. In the F# world, whole different matter. And when I say suboptimal, most of the time you're not going to notice the difference. If you want a little bit of a metaphor, then OOP is always going to be the fast, nippy style of coding. And if absolutely squeezing every little bit of performance out of your program is important, like, for example, you're writing a VR application where you've got 2 HD streams, one into each eye, you probably want to go really low level, and you probably don't even want to use like native parsers. You probably want to write your own that shift binary bits around and stuff like that. But the other disadvantage, though, of the OOP approach, it might be quick, also quite easy to make it fail, as compared to functional. Functional is more like this guy. It may not be the fastest, but it is going to lumber through your park, executing and doing things correctly, and it'll be very hard to stop it once you've started rolling. That's the thing we bring to the table. So which direction you go is a matter of what the constraints of your project are. But chances are the vast majority of us, like myself, write business applications for internal consumption, and performance is not going to be that massive of a deal at the level we're talking about. Especially when these days you can quite easily just click a button and an extra slot of RAM goes into a virtual machine somewhere, and basically no one really cares. It's a lot cheaper than all the extra development time you'd otherwise need. So let's talk about immutability. This is one of our basic concepts. Immutability is the idea that all variables, once set, may not be changed again, ever. And all of their properties may never be changed. Everything is read-only from the moment that you define it. So what does this look like? Well, here's a silly example, and I'm trying to explain why this is useful. This is a silly example based on the best TV series in the entire world. It is called Doctor Who. Does everybody know Doctor Who? Yeah, you got a thumbs over there. Nice, very good. Yes, if you look in the dictionary, it is actually there listed as best TV series ever made. It doesn't even have a disappointing ending, unlike Game of Thrones, in that it has no ending. It hasn't had an ending since it started in 1963. So, okay, this is some silly made-up code because it doesn't really matter. I don't want to get too bogged down in nonsense like this. And so I've instantiated a new doctor. That's the main character of my TV series. And I've given him a number and I've given him a name. That is the actor there, the boss himself, William Hartnell, the original doctor. Done some stuff. It doesn't really matter. And then I'm going to write the name of the actor out onto the console. Seems simple, right? Well, if I run this code, it says Humphrey Bogart. What happened there? I mean, I instantiated him, and then I did some stuff and passed the doctor into each function, and Humphrey Bogart popped out. What happened? Well, okay, this is a silly made-up example. What happens is that inside one of these functions, I changed the actor name. Aren't I sneaky? But you can do that sort of thing in OOP. You can pass an object into something, and you can't necessarily guarantee that it remains the same in the outside world because you've given the inside world free range to do whatever they want with it. And that's really dangerous and unpredictable. And it can make debugging an absolute nightmare. I have had problems with this exact thing. So imagine, for example, if it wasn't in that top-level function, maybe it was in a sub-function of it, or a sub-sub-function, or a sub-sub-sub-function. And what if the logic that turns William Hartnell into Humphrey Bogart is split over 3 different places? Now, this might seem ridiculous, but I have seen this exact scenario played out in a company I once worked for. And it wasn't turning William Hartnell into Humphrey Bogart, but nevertheless, that idea is real. And it might be that there are either 3 different things that have to line up just so to make it happen, or it might be there are 3 different conditions split over different areas of the code base. And in my case, for the company I was working for, those bits of logic weren't even in C# necessarily. There was the top-level project, there was a bottom-level DLL, which was a separate project, there was another DLL below that, there was another project, and then there was the store procedures, and then there was some database code besides them. So the business would turn around and say, there's 3 rules that do this. We just want to add a 4th rule. Okay, wonderful. Now I've got to go hunting down where those rules even are. You don't get this problem in functional because everything's read-only. You tend to sort of turn the program on its head and look at the end first and work your way backwards. So here is a bit of mathematical working. Now, I don't know if this is the correct term for everyone here, but this is the idea that you get if you were taking a maths exam and they wanted you to show your working, this is show all the intermediate steps so that even if you get the answer wrong, we can still give you some half marks or something like that to say, well, you got the first 3 lines wrong and then right, and then you went wrong. So this is a bit of mathematical working. This is the inspiration behind the style of functional programming. Each line is a definition. It's not a variable, it's a definition. And that's how we write our programs. Let A equals 10. The definition of A is 10. The definition of B is 15. F is a function. It's defined as a 2-parameter function that squares the 2 and adds them together and takes the square root. This is basically Pythagoras. And so on. Those are definitions. So every time you run this program, you will get the exact same number at the end, 18.03. It's predictable. We know exactly what we're getting, and that is how we write our programs. That's how I would do this in C#. Again, everything's a definition. I am not taking A and then adding 15 or, well, whatever. I'm not modifying anything, is my point. So how would I handle this? Well, I'd probably do something like make a function explicitly as dress as Humphrey Bogart, and I would return a new doctor object based on the old one. So rather than modify the existing one, I'd create a new one with modifications. And that is how we handle state in functional. If anyone has done Redux in the React world, you've basically got the idea of how we do this. Every handle of state involves take the old object, take a command, take some parameter bits and pieces, stitch it all together and make a new state object. The old state object may be kept or may be thrown away, but that's for the outside world to determine, not the child function. Everything has its job. I might even go a step more generic and maybe even just pass in a string that can be the disguised as anything. So I'd get something like this now. I instantiate my object, I do some functions, I've got a new variable called disguise doctor, and that is equal to the new modified form. The original one is left intact, which is when I go down to the console to write line, I can explicitly decide which, if any, or both actors I wish to display. So no unpredictability. I know what I have because I've defined it that way. And I know, because everything is read-only, that no one is going to do any monkey business with any of my objects that I pass down. Here's another example of something. You can do a calculate price. That's something where you might classically do a load of modification. Get a price, get a price object, get the price out of it, multiply VAT, multiply by some sort of markup, and then return. Whereas in functional world, we might do something more like this. Once again, based on maths. The idea is that each line defines a part of the process and is read-only. And then if I wanted to debug this because I was getting the wrong value out, I could put a breakpoint on the return, and every single intermediate step is still in existence, and I can examine it in one go, and it wouldn't be very difficult to work out precisely which function is the one that is causing the problem, making it a lot easier for me to work out where the problem is. So a challenge for anyone, if nothing else that you could do after this talk, try treating absolutely all of your variables as read-only. Now, you can't enforce that in C#. That's not a thing we've got. It has been bandied around once in a while, but if they started enforcing immutability, it would break every code base in all of the world. So they're not going to do it. So no void types. Don't have a function that returns void either. Because if something returns void, that is, it doesn't return anything, it's clearly doing something. And in the functional world, every function has to return something. So make up a code base which has no changes of variable values, and every function has a return type. Give that a go, and I almost guarantee that you'll end up with better code at the end of it. Yes, thank you, Elsa. Right. Let's talk about results-oriented architecture, because this is the way that we turn, the way that we actually This is kind of the way we structure a whole functional program. We focus on the results, not the how do we get there, not the process or the journey. We focus on the results we expect to see at the end. This is a TSQL statement. Now, I've kind of made this up, but this is a valid TSQL statement as far as I'm aware. And TSQL is actually the most common form of declarative programming that any of you are likely to have encountered, because it is declarative. And what is the order of execution in this function, in this query? It's something like this. First the from, then the on within the left join, then the left join itself, then the where, then the group by, then the having, and then the select, then the items from the select, and then finally the order by at the end. Does it matter that the order of execution is wildly different to the order in which we wrote those things? No. Doesn't matter. And we focus on the results. The first thing written is the select. And that is results-oriented architecture. First start with what you want, and then go into the detail of where we got it from. That's how we write these things. So this is a silly made-up example of how we might go about getting some sort of complex object. Now, there are two definitions of property C and property D here. These are all nonsense that I made up because it doesn't really matter. But the point is that there are two definitions of C and two definitions of D. And it can even get more complicated. What if I put a branching if statement inside that? There are now 4 definitions of C and 4 of D. If we change what C means, what its type is, what its meaning is to the business, we've got to go hunting around a whole load of different places in order to make sure that everything now works. And I've seen stuff like this. I used to work for an international company where they used to have logic which was branched based on which country the account is based in. So it'd be something like if Brazil then, and then underneath that you'd have another if, and then there could be clusters of countries that branch and then branch and then branch, and you end up with code that looks rather more like family trees than reasonable code, and it becomes very hard to manage very fast if you continue to work in that style. So instead, I would work more like this. Start at the end. I want an object, which is my custom object, property A, B, C, and D, one single definition of each. Maybe use a ternary if statement or something. You can use a switch expression. Those are pretty cool. And those were inserted to aid with implementing the functional paradigm. That's something called pattern matching. So that would make this far simpler and easy to work in because we focused on the results, not on the process. And if there are more complicated bits of logic behind C and D, then just wrap that into a subfunction and so on. Functional tends to work best when you split down your code into many smaller functions, all of which have ideally a single purpose. It means that you write a lot of functions, but it also makes it very easy to work out where you're going to make your changes. Because functional programs like ogres have layers. We start at when you are examining a functional program, you start at the outer layer, the results layer, the final what are we going to get at the end layer. And if you care to go further, and if you need to change it, you go a level deeper and a level deeper until you find the level that you actually want to work in, and that's where you start making your changes. A complaint I often get with this sort of approach is, well, I can't see how it does it, and my response is usually, I don't really care. If it does what it says, I trust it that it does what it says. If it didn't do what it says, I'm going to go under there and work out why it's not doing what it says. And then once it's fixed, it's fixed. Do I need to worry about the minutiae under the surface? Generally not. And that's fine. Okay, predictable code with no side effects. How do we do this? So, I'm going to use an awful lot of link and some other things. Now, adds is easy. This is a ternary if statement, which strictly speaking isn't a statement, it's more like a function, so this is perfectly acceptable. Statements are things we do not use in functional programming. A statement is something which does not evaluate to an actual hardened value. So if, while, for each, we don't use any of that stuff. Excuse me. Okay, so removing if statements is relatively easy if we use things like ternary ifs, and you can use switches, and so on. These are side effect, yeah. So that's side effect free, because we have got an is null or white space check, and it will always return the same results whatever we do. The first one is also perfectly side effect free. Given A, given B, it will always return A plus B. So there's no way for us to put in an invalid integer value. Even if you put negatives in, you'll still get the correct answer because a negative is a valid integer. If you put a null into the say hello, then it's still going to return a value. It's a default response, but still, nothing unexpected will happen. These functions are what we call pure, side effect free and predictable. These, on the other hand, are not pure. So this new add adds A and B to a total and then returns the total. It'll return a different value every single time. That's not pure. That's not good for functional. In functional, we want everything to be pure. That is, you always expect, given these same parameters in, you always get the same value back. We want it to be predictable. The same with the say hello there. It's actually connecting to an internal property of whatever class we're in, and it doesn't do a null check, so the possibility exists there for an unhandled null exception. And the third one there has a datetime.now in. Well, of course, that's going to be different every single time you call it because the datetime.now is literally different every single time you call it. So the reason we do this sort of thing is that you end up with programs that are more robust. If everything is more predictable, if you could always rely on a function to be completely dependable and do the exact same thing you expect every single time, you get a much better quality code base. And it's easier to test as well, because if you really do functional all the way properly, you're not worrying much about state objects, about setting up your class and all that sort of thing. Generally speaking, the ideal is that you pass a function everything it needs into its parameters, which makes it very easy to test. In true functional code, you don't need mocks, because we don't really have classes as such. Although this is C#, so it's a hybrid environment, you'll have to do what you have to do. There are some areas of the code base that are never going to support pure functional because that's the way it is, because they're really old. Certainly I've been messing recently with the mail client. That's not going to get functional anytime soon. I don't even think that's got an interface. Right. Functions over statements. So as I say, statements, that's these guys. If, for each, for, while, do while. In a functional program, we don't use them. So how can we replace these statements with something else? Well, the if is easy. Switch expressions are brilliant. If you're not already using switch expressions, you should absolutely be using switch expressions. They are incredible. There's really no need to ever write another if statement ever again, really, because switch expressions do all of it. This is just a set of ifs and else ifs and so on. There we go, perfectly represented. And a switch expression is a function. So you can reference it as a function, use it as a function. Okay, you can switch based on the properties or the actual type based on the parent type. And these days, as of one of the more recent versions of C#, you can even switch based on the contents of an array. That's amazing. So there really isn't any reason whatsoever to write an if statement. How about this, though? What if there were two values? I mean, switch is great if you want to do a whole load of complex logic based on a single property. Well, what if there are two and you need to do two? Well, that's really not terribly difficult. What you do is you just stick them in a tuple and then switch on the tuple, and there we go. Once again, back to a switch expression. Easy. See, none of this is hard. A for each is pretty much easy. It's a select. Is anybody not okay with a select? Nah, that's all right. That's what I thought. So it's easy, isn't it? You don't need a for each anymore because select does all of that for you. There are a couple of edge cases. How do we deal with those? Well, there's aggregating, which is compressing an array of objects down to a single object. Well, LINQ has got that covered, because we've got things like .sum and average and all that sort of thing. But also there is the grown-ups version, which is .aggregate. .aggregate is the complex version of how do I compile down a list of items into a single item. What you do is you provided a function which takes the running state compiled so far and a function which is equal to the current running state plus the current item, and then that function needs to return a new updated state, and then you just applies that function to every single element in the entire array, and what you get back is a single item. So have a play with aggregate. It seems to be one of those great features, those great features of C# that hardly anyone knows about, and I will carry on banging on about until everybody's using it, because aggregate is incredible. What if I need to multiply together two consecutive arrays? Well, you can't do that with a select statement, can you? You can. Zip. Does anybody know about zip? I got like a couple of folks. So you folks are cool. Zip is brilliant. Okay, zip basically means take this array, place them side by side, and I'm going to give you a new enumerable which has got a first item and a second item in it, and it enumerates through the whole lot, and then you've got the same consecutive elements in the two arrays laid side by side, which means I can create a new array based on two arrays where each element of the new one is element naught of the first one multiplied by element naught of the second, and then element one of the first and element one of the second, and so on until I've gone through the entire array with them all placed side by side. So there you go. You don't need to do a for each for that. What if I needed to compare consecutive elements of an array? Well, surely that needs to be a for loop. Like I need to go minus to item I and item I minus 1. Don't we need to do that in a for loop? Nope, don't have to. Zip again. So, what you do, take the first item, take the item, skip one, which basically makes a new enumerable based on the old one, except it's skipped a place. Then zip that again with the original, and what you have got is two consecutive elements of the array being compared through a single enumerable. It's basically a sort of computing version of tying a knot, but it works just fine, and it means that we can compare consecutive elements without needing a for loop. I thought that was quite cool. Okay, what if we need the iterator value? What if we need the number out of it? There's a couple of ways of doing this. One is to use the overload of select, which gives you that. There's another way if you need to do something more complicated, enumerable.range. Enumerable.range generates a new array starting at position whatever and with a value that's normally going to be 0 and then going on until length, which is wherever you stop. So if you say enumerable.range 1 and 7, what you get is an array that has the values 1, 2, 3, 4, 5, 6, 7, like that. And then zip with that, and then we've got ourselves an enumerator value and the original array, and zip them together, and we can reference both. So that works too. There's all sorts of tricks that you can play, and link pretty much does everything, because hardly anyone, I think, has really dived fully into the depths of what link is capable of doing. What about while loops? Now, that's a tricky one. So those previous loops are what we call definite loops. Definite loops have a definite ending. They are going to start here, they are going to finish here. That's easy. An indefinite loop is a loop that is continue until I say otherwise. And there's no great way of handling that, I'm afraid, in C# in a functional style. I mean, the classic method is recursion. You shouldn't really be doing that. Not unless you really know exactly how long your recursion is likely to be, or unless you have no other choice. But otherwise, if you've got an array with, say, 1 million items in it, and you're going to try doing recursion through that, then what you're going to end up with is probably a stack overload. So don't do it. The method we use is called trampolining for reasons that I do not understand. Nevertheless, this is what it is called. Okay, so this is a while loop, which is just going to add 1 to a value until we reach a predetermined value, which is 10. So it's just simple, just to keep things not too complicated. And I could create an extension method like this, call it do while, pass in 2 functions. The first is the condition by which we decide whether to continue or not. The other is what you do if you are continuing. Underneath the surface, on the other hand, though, it's a while loop. Like, fundamentally, it's the only way of doing it. It's just the way it is. The only other way I'm aware of is using a goto statement. Now, believe it or not, gotos, and I remember these from my days as a basic program on a ZX Spectrum, goto is still a thing in C#. It still exists. Probably shouldn't use it, but it does still exist. But really all you're doing is implementing a while loop. You're just using a goto, and you'll need an if statement in there somewhere to make it work, so you've achieved nothing. Sadly, this is about it. So if you're doing functional style C#, your choices really are use a while loop or hide a while loop. I leave it to you which you want to do. That's the way it is. If that's bothering you, move over to F#, because F# has a compiler trick which will allow you to do safe tail recursion. What it actually does, if you have a look in the intermediate language, is hide a while loop somewhere. So once again, we're back where we started. It's the only way to efficiently have an indefinite loop. It's the way it is. Okay, project structure. How do we structure a functional program? This is an architectural style called imperative shell functional core. I use a slightly modified version of this, but the idea is that there is the outside world, which is full of scary things with side effects like databases and websites and users, and they are going to interact with our application, and they are unpredictable because any number of things can happen. There could be HTTP problems, there could be the user. All sorts of terrible stuff can happen that's hard to predict. And so what we need to do is create a buffer zone in the outer ring of our application that buffers side effects into something that's manageable and then passes these handled side effect versions of those interactions into the functional core of our application where everything is purely functional. And the idea is to make that functional zone as big as possible and then create as little as possible in the imperative core around the outside. Now, I add a little extra donut hole in the middle because I write extension methods to allow a bit more functional code to be written, and I generally have to hide bits of imperative in there because that's the way it is, like hiding while loops. There are other reasons why I might do this, but because sometimes that's the only way. But at least if I'm hiding a while loop in the middle of my program, there is only one. And if one day Microsoft turn around and find us another way of doing a side effect functional style indefinite loop, then I'll probably replace that extension method and then everything is purely functional again. But for now, that is the only way. How do we handle side effects? Well, this is a cat in a box. Has everybody heard of Schrödinger's cat? Okay, so this is how I'm going to describe something which is called a discriminated union, which is a type which is one of several different types, and you don't know which until you look. Rather like Schrödinger's cat is of type cat, but it is not actually cat. It is a live cat or dead cat, and you don't know which until you open the box. So that's how you want to think of a discriminated union. It's a box with cat written on it, and you're going to pass that from person to person to person. Most of us are probably going to be wise enough to know that we're not going to open this box because there is either a dead cat or an enraged living cat that's wondering why it was just put in a box. Either way, it does not end well for us. So if you care, you open and look. If you don't, you just pass it around and reference it by the label. But there is no actual object called cat. It's a container for one or more actual types. That's what a discriminated union is. If anyone works in TypeScript, I believe union types are a thing in TypeScript. This is a discriminated union. So in this case, we're going to make a union where there is the happy path, where everything worked out just fine and it was all good and we got our data, or things didn't go so well. And those are going to be the two types inside our union type. So this is called a result, and it results in either success or failure. And the properties of those two types are going to be different based on whatever happened. The success may be empty, or it may contain a return value. The failure will probably hold an exception or a message describing what happened that went wrong. And there's how I would do it at the moment. Apparently, discriminated unions are coming in C#. I don't know exactly when they're landing, and I understand from people cleverer than I am that there is some pretty heavy technical problems to overcome, but nevertheless, they are coming. But for now, this is how I do it. I make a public interface of type result of T, meaning it's a container of T, whatever T is, that's a generic, so it can contain anything. Make it a public record struct. That should be also read-only, which returns a success, which inherits from result, meaning it's a type of result, but it contains a value. Otherwise, it's got a captured exception coming out of it. So if you don't care what the result is, just pass result around. If you care, then do something like a switch expression to convert your result into the specific type that you want to get at the end. And here's how I might fire one of these off. I'm not going to bother putting the details of how we implemented this because it doesn't matter, but just imagine some implementation behind that comment there. So I go and try and get my data, and if I got my data back, then I'm going to return a new success containing the data. Otherwise, if the catch was triggered, that is, an exception occurred, then I'm going to return a new error and pass back the captured exception. And then everywhere else that ever looks at this thing could check to see whether it was a success or a failure. And then knowing it was a success, we know we can mess around with this data and use it. If it's a failure, then we know not to bother and not do anything. And that's it. That's easy to handle. Here's how I might compose it down at the other side. This is down at the controller, which is usually for me the place where I am going to collapse these two possible quantum states down to a single thing, and that's at the controller where I'm going to pass a message to the user, which is in this case a string. But it might be a complex object. It might be something like a page render or something like that. So you might use this to determine which page I render, either the correct view or the error view, whatever. There's lots of things you could do with it. But the point is, up until this point, there are two states. And now, finally, at the end, we're going to collapse down to one. This is kind of what it might look like under the surface as we pass around the areas of our business. So you make your web API call, which then splits into two possible states, success or failure. We put that into an envelope called result and then pass that around. Now, there is a function, there's a way of accessing the results internals to do to make changes to the object inside, and it's an extension method which will allow you to interact with it and then wrap it back into a result so that you can pass it around in the same manner again, but it will only actually make the change if the result was a success. And this is how you do that change. So take out the result, run a function which says check if it's a success. If it's a success, convert it to something else inside the envelope, and then put it back into a result and send it on. Otherwise, if it is not a success, it's a failure, don't run the function that does the conversion of old type into new type and put it back into a result. So whichever path we go down, we go from result, we end up with a result. It's like a chain of evidence, if you like, in a court case when you have to, if you open it, you have to, there are rules about how you seal it back up again. And it's called bind. That's one word for it. I've also heard it called map. The problem with map is that there's also AutoMapper out there, which also has a function called map, so I don't like to use map because that can get confusing if you want to say use AutoMapper and this. So I tend to stick with bind. And so in this case, what I'm doing is I've got myself a result type, and that is raw string data. That's a result of string, called bind, and inside that I am telling it how I want to convert the result of string into something else, that is parse data into a complex object, and then return, which means I've got a result of a something fun object. Under the surface, it looks like this. It's a switch expression. You can go really complicated with this. I'd probably wrap a try-catch around that as well, just to stop the possibility of the function that's being passed in from causing a problem as well. And I might do one or two other things, but that's the basic principle of what we're doing. Scott Vlashin calls this railway-oriented architecture. You have kind of two paths, a happy path and a sad path. The happy path at the top keeps running functions, and if at any point something fails, it switches down to the sad path, and then it never executes anything again. So you can have one chain of functions, one after the other, and if any of them fail, then it just stops executing anything further in the chain. This is one of the simplest implementations of something called a monad. I am not going to talk further on monads, but if you ever wanted to know, that's basically what one is. Strictly speaking, this is a functor, but don't. You don't need to know this stuff. No one cares. No one I care about anyway. And you could do stuff like this. Let's say that we have an execute stored procedure function, and each of these returns a result. So you could do execute stored procedure, then bind, run 2, bind, run 3. So in this case, if stored procedure 2 failed, and instead of returning a success, it returns a failure, it won't execute stored procedure 3. So imagine all of the checks against null and try catches and all of that you'd have to write if you wrote this as normal object-oriented style code. You don't have to do it here. It's just simple. It's far simpler in many ways than the object-oriented alternative. Domain modeling. So I've talked before about discriminated unions. This is another way of thinking of using them. Let's imagine that we have a name class. Okay, well, this is easily how we would store a fairly typical European name. I have chosen British actor Benedict Timothy Carlton Cumberbatch. What sort of a name is that? Fine. We've got a title, which will typically be Mr., Mrs., Ms., and one or two others. First name, an enumerable of middle names, because some people have none. Some people, like me, have one. It's John, and so on and so forth. And then a last name. So that means that we can write a composed greeting, which is hello, title, first name, middle names converted into a list with a space in between, and last name. Easy peasy. This is Jackie Chan. Jackie Chan is from Hong Kong. Now, can we put Jackie Chan's name in here? Well, the answer is no, you can't. Not without having to get very creative. Chinese names do not work like European names. For example, the title is not, for him, I believe, would be Shan Sheng. The problem with Shan Sheng, okay, we can put it in there in title, it goes at the end. You put the title after the name to be correct. So you would be already mangling his name if you put Shan Sheng at the beginning. His first name is Fang and his last name Shilong. That is his real name. Problems with those, the names in China are written the other way round. So in fact, his personal name is Shilong and his surname is Fang. You could put them the other way round, but then what you're doing is putting a first name, a family name in the wrong place, and you've mangled your data structure to try and kind of make it work. And also, he has got a courtesy name, which he is often known by, that being Jackie. So where do you put that? You could make it a middle name, but once again, you are butchering the data structure to make this work. Well, the answer is, instead, you could put this in a union. Okay, we can make an interface called name, put nothing inside it, and implement off this a couple of times. Once as I said, British name for Benedict Cumberbatch, and once as Chinese name, which has got types in it which are meaningful to each very specific circumstance. So we can keep the British name the same, but for Chinese name, for Jackie Chan, then we can have title, family name, personal name, and courtesy name. Those are fields which make sense to that sort of a name, and then we can have a different style of implementation of the write the name out for each of those types. So the point is that we've got the wrapper type, and inside that there may be one or more different types underneath it, and then we can handle each one using a switch expression. So it makes modeling your domain much simpler because you can be far more specific for cases like this, where you might have more than one type. Otherwise, what you're going to have to do is put things like an enum in there to tell you which region the name comes from, have various nullable fields which may or may not have values based on what the value of the enum is, and that is messy. This is simple and elegant. And I think it's a much better system for modeling cases like this. So, to wrap up, as I think, how are we doing for time? Oops. Don't tell anyone. I think we'll get away with it. But once again, if anyone wants to have a go, this is my book. Do be warned, I wrote this mostly between the hours of midnight and 3 a.m. because I have small children. It's the only time the house is quiet. So the book is really quite random. I will be talking a lot of very hardcore functional content in this, but you'll also find out who is my favorite James Bond and who is this pizza for. It's not for me. You'll see. It's also the only technical book I think ever with a post-credit scene and Amitabh Bachchan in the credits because he's an awesome Bollywood actor. Anyway, I told you it was random, but the technical content's legitimate. So feel free to have a go. I'll even sign it if you ever buy a copy. Right, and thank you very much. I think we're out of time, so thank you.